In the sections building up to this, we've looked at complex numbers, we've looked at polar form, how to convert from polar form to rectangular form or complex number form. Here are those formulas. These same four formulas are in the calculator under the angle section. So if I go into second and angle, we were taking a look at functions 5, 6, 7, and 8, right? Formula number 5, this is to find R. Formula number 6, this is to find theta. Formula number 7, this is used to find X. And then formula number 8 is used to find Y. So we've converted from one form to the other form. The last time we met, we took a look at a couple of formulas to multiply complex numbers in trig form. We also taken a look at the formula to divide complex numbers in polar form. Today we're going to go a little bit further in the last section, and we're going to raise complex numbers in trig forms to powers. All right. And we're going to introduce something called the De Moivre's theorem. Right, so just going into the problems themselves. Now, since this semester they put the formulas, they've actually embedded the formulas in the problem. And for this particular problem, they give us these two formulas. Now, this first formula that you see, that is simply a complex number in polar trig form. The second formula that you see, this is actually the power of a complex number in trig form. So just to write this over here, this is the power, or find the power of a number, of a complex number in trig form. Okay, first off, you need to have your number in trig form. Once your number is in trig form, I'm just going to write it out like this. R times the cosine of theta plus I times the sine of theta, right, raised to some power n. That's going to equal to R raised to the n power times the cosine of n times theta plus the sine of n times theta. I can also write this formula out in a compact form, and that's actually what you see in XYZ homework. Or if you have your complex number in compact trig form, it would look like this: R cis theta. Right, and we want to raise that to power of n. I will simply take my moduli, I would raise that to the nth power, and I would multiply n times our argument. Right, so here are the two formulas to find the power of a complex number in trig form. Right, so let's take a look at the example. And this is number 1. And it says, for the following exercise, find the power of the complex number in polar form. So it says find z raised to the third power when Z is equal to 5 cis 5 cis 30 degrees. So I'm going to kind of write it out like this. So I'm going to take my number that's in trig of polar form, five cis 30 degrees. I'm going to take that number and I'm going to raise it to the third power. And I'm going to erase these momentarily, I guess. All right, so then if I take a look at the formula says that I take my modulus and raise that to my power. So I'm going to take 5. I'm going to raise that to the third power. And then I want to multiply my argument times my power. So this is 5 to the third power cis 3 times 30 degrees. Right, I raise my modulus to the third power. I also multiply my argument by 3. So 5 to the third power is 125 cis 90 degrees. Right, so now they don't want us to go any further because I didn't actually copy out my answer choice completely, but it'll be 125 cis 90 degrees. So when we take 5 cis 30, raise that to the third power. We're going to do much the same thing for problem number 2. Right. Again, we want to take our complex number in polar form, which is 2 cis power 3. And we want to raise that to the third power. So I'm going to use the formula, and the formula says I'm going to take my modulus. I'm going to raise that to my power. In this case, the power is 3. I'm also going to take my argument, and I'm going to multiply my argument times 3. So that's 3 times pi over 3. And now I just want to simplify. Right? 2 to the third power is 8. When I multiply 3 times pi over 3, the 3's cancel. So my final answer is 8 times the cis of pi in compact form. All right. So the first two, right, we simply use a formula. For the last couple of problems, okay, it says use de Moivre's theorem, okay, and de Moivre's theorem is that power theorem we just looked at. I'm using Moivre's theorem to evaluate the expression. Now, without de Moivre's theorem, the way that you would actually answer this is you would take -3 plus I and you would multiply that by itself 8 times. Right? So like this could be like -3 plus 3I times -3 plus 3I. Write that out 8 times. 1, 2, 3, 4, 5, 6. And you don't have to actually write this out. 7, 8. So now algebraically, that's what you would do. You would just take -3 plus 3I, and you will multiply that by itself 8 times. And that would probably take you some time to do. Or we could use de Moivre's theorem, right? But in order to use de Moivre's theorem, and de Moivre's theorem is basically this. I erased it, but R cis theta to the nth power, that's equal to R to the nth power cis n times theta. Okay. All right, so what we just did, technically it has a name, and that name is called the Moore's theorem. The thing about the Moore's theorem is that in order to use it, you have to feed it a complex number in trig form. Which means for this problem, you have to convert this complex number to trig form, and then you can raise it to a power. All right, so let's write out some steps for doing that. All right, so the first thing I'm going to do is convert this complex number to trig form. So if you remember back, the first thing we have to do is sketch. So if I were to sketch -3 plus 3i, and the only thing my sketch does is it locates a quadrant for my vector. That way I can kind of narrow down my direction angle. So just remember, if you're in the first quadrant, both of your signs are positive. If you're in the second quadrant, your x variable is negative, the y variable is positive. If you're in the fourth quadrant, both x and y are negative. And if you're in the fourth quadrant, x is positive and y is negative. So if I look at my complex number, my real number portion is negative and my imaginary portion is positive. So that will put this complex number in the second quadrant. So that means that my direction angle must be in between pi over 2 and pi, or 90 degrees and 180 degrees. All right, so the second thing we're going to do is find R. So we can find R two ways. We can use a formula, or we could use a calculator function. So I'll do them both ways. So if we wanted to find R by hand, remember there's that formula. R is equal to x squared plus y squared. X is -3. And y, which is the coefficient of my imaginary unit I, is +3. So when I put this into my formula, this is x, which is -3 squared, plus y, which is 3 squared. Okay, that's 9 plus 9. So R is equal to the square root of 18. Now, if I put this in my calculator, it's not actually going to give me the square root of 18. It's going to give me that approximate value. But just to show how to find R in the calculator, I'm going to go into angle, which is second in apps. I'm going to scroll down to the fifth function. I'm going to put in my x coordinate, which is -3, comma, my y coordinate, which is +3. And when I hit enter, it gives me 4.24, which is the square root of 18. Right? Those are the exact same values. The next thing I'm going to do is find theta. So theta is equal to the arctangent of y over x. So again, y is equal to 3, and x is -3. So theta is equal to the arctangent of 3 over 3 over negative 3, which is negative 1. Right. And if I use a calculator to calculate the arctangent of negative 1, I get 45 degrees, or negative 45 degrees. But if I look back at my sketch, my angle should be in quadrant number 2. A negative 45 degree angle is in quadrant number 4. So in order for me to put my angle in the right quadrant, I have to add 180. So negative 45 plus 180 should give us 135. I can also use a formula in the calculator. Well, let me just write down what I did. I got negative 45 degrees. I added 180, so theta is 135. Right. If I use my calculator, I'm going to use that 6 function. I can put in my x coordinate, which is negative 3. I can put my y coordinate, which is positive 3. And when I use the 6 function, it gives me exactly 135. Sometimes they will give you exactly what you want. Sometimes you have to add 180. Other times you have to add 360. But that's why the sketch is very important. All right. So we're going to take negative 3 plus 3i. We're going to put it all together. Negative 3 plus 3i to the 8th power. Negative 3 plus 3i as in trig form is going to be the square root of 18 cis 135 degrees. We're going to raise everything to the 8th power. So now I'm going to use the Moore's theorem. So the only thing I did here was I've rewritten the complex number in trig form. Now I'm going to use the Moore's theorem. So the Moore's theorem says we take the modulus, we're going to raise it to, in this case, the 8th power, times cis of 8 times 135 degrees. So I'm going to take the square root of 18. I'm going to raise that to the 8th power. And I get 104,976. And I'm going to expand it out times the cosine of 135 degrees plus I times this, well, excuse me, I got to multiply 8 times 135. 8 times 135 is 1080. So I have 104,976 times the cosine of 1080 plus I times the sine of 1080. And now I'm going to convert it back to a complex number. So I'm going to distribute. Oops. So I'm going to calculate these individually. The cosine of 1080 gives us, well, I'm in degree mode because I'm putting in a degree measure. The cosine of 1080 is 1 plus the sine of 1080 is 0, or 0i. And then once I distribute, 104,976 times 1 is 104,976. 104,976 times 0i is 0. So my final solution is 104,976. Right, so once you expand -3 plus 3i to the 8th power, you should get 104,976. And we'll take a look at the last problem. There's only 4 problems in this set. And we'll pretty much actually do the same thing. Take a complex number, raise it to some power. So we're going to take the complex number, convert it to trig form, and use the formula. So if we just repeat those steps, the first step is always a sketch. So 2 square root of 3 minus 2i, I believe that should be in the 4th quadrant. Minus 2i. So that I know that my direction angle should be between 270 and 360 degrees. Right. The second thing we're going to do is find R. So here I'm just going to strictly use the calculator function. So I'm going to go into angle. To find R, it is the 5th function. Bless you. All right. So I'm going to use that 5th function. I'm going to put in 2 times the square root of 3. Make sure you close off your square root, comma, -2. You have to keep your sign as well as your coefficient. And you get 4. So R is going to equal to 4. The next thing we're going to do is find theta. So I'm going to use the 6th function. So if I go back in the angle, second, and I'm going to use the 6th function. I'm going to put in x, which is 2 square root of 3. 2 times the square root of 3. Close off its square root. My y value is -2. And if we hit enter, we get -30 degrees. I mean, -30 degrees, it is in a 4th quadrant. The only thing it is that it's negative. So I can re-express it as a positive angle by adding 360. So I have a 330-degree angle. All right, so now we can convert the complex number to trig form. 2 square root of 3 minus 2i, and that's raised to the third power. That equals to 4 cis 330 degrees raised to the fourth power, or excuse me, raised to the third power. And then the Morse theorem tells us that we can take our modulus, which is 4, raise that to the third power, cis 3 times 330 degrees. Four to the third power is 64. 3 times 330 is 990. So I'm going to write this out in long form. So it's cosine 990 plus I times the sine of 990. All right. So now I'm going to find the cosine and the sine for 990. So I'm going to use a calculator. So the cosine, make sure you're in degree mode, right? Because we're putting in a degree measure. The cosine of 990 degrees is 0. The sine of 990 degrees is -1. So that's minus I. And now if I distribute, 64 times 0 is 0. 64 times negative I is negative 64I. All right, any questions about the Morse theorem?
How would you put in answers where it gives you a long decimal? Would you round it to 10th place? Like if I were to do 3 root 2 to the third power, or root 18 to the third power, I get a decimal. I don't really get a clean number.
I think you will get a, let's see, the square root of 18 to the third power.
Yeah.
Does it tell you to round your final answer to the?
Not that I see. I don't even know.
And that was for which question?
I had it for number 4.
Number 4.
3 minus 3 I to the third.
3 minus 3I to the third power. That was yours.
3 root 3 minus 3 I to the third.
Minus 3I to the third power. This was it. Okay. So when you convert that to a trig form, so if you sketch it out, the x is positive, the y is negative, so that's going to be in the fourth quadrant, right? So that's between 270 and 360. Once you find R, let me just see what happens. So I'm just going to use the calculator. So this is 3 square root of 3. Close off that square root. So that's 6. And if I find theta, I'm going to use that 6 function. You get negative 30, but you got to add 360, right? Because negative 30 is in the full quadrant, but the direction angle has to be positive. So if I add 360, I get 330. So my angle is 330. So I can rewrite 3 squared root of 3 minus 3i in trig form as 6 cis 330 degrees. And we're going to raise that to the third power. So now we can apply De Moivre's theorem. So I could take 6, raise that to the third power. So you don't actually take that square root of 18 and raise it to the third.
How did you do the 3 times root 3 to get 6 for your R?
To get 6,
Yeah.
I just use a calculator. I can show you how to do it by hand. Let's see. So R is equal to the square root of x squared plus y squared. X is 3 square root of 3. Y is negative 3. So I have to take x, which is 3 square root of 3, and I got to square that. Plus, I have to take y, which is negative 3, and I have to square that. So now when you square 3 times the square root of 3, right, there's something called the product of a power from algebra. So it says a times b to the nth power is a to the nth power times b to the nth power. So 3 square root of 3 squared, you have to raise 3 to the second power, and then you have to raise square root of 3 to the second power. So 3 squared is 9. The squared and the squared cancel. 9 times 3 is going to be 27. You got it? Okay. So this 3 squared to 3 squared, that's 27. Plus 3 squared is 9. R is equal to the square root of 36, which is 6. But I use the calculator function to simplify all that. If you're using the calculator, just make sure you close off that square root. So like if I go in the angle and I can use this fifth function, when I put in 3 times the square root of 3, this is 3, and then it's a square root. So notice they gave me a begin parenthesis. So I put in my 3, and then you must close it off. Because without closing it off and finishing, it's going to give you an error. So I close off my square root. My y coordinate is negative 3, the coefficient. So make sure you put in a negative 3, and then that gives you 6.
Yeah.
Okay. All right. So then just to finish this, so you raise 6 to the third, and then you have to multiply 3 times 330. And so 6 to the third power is 216. And I'm going to write this out in long form. 216 times the cosine of 990 plus I times the sine of 990. And then the cosine for 990, we just found that as, was it 0? The cosine of 990 is 0. The sine of 990 is -1. So then you should get negative 216i.